Hello everybody and welcome to another mystery box function challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. You can use the link in the description to try this out on your own, and when you've got an idea, come on back and see if we get the same thing. All right, I'm going to start with a 0. Oh, so 0 gives us infinity, so maybe, well, right away I'm thinking a rational function, so let me just make a note of that. So maybe it's something in that family of 1 over x. That's where we often see that infinity error. Let's get a few more values. How about 1? Now there we're seeing a non-repeating decimal, and we most often get those with square root functions or with trig functions. Let's do some more here. How about 2? Okay, we've got a little bit of a, well, it's hard to tell exactly what that is. Let's try another value. Oh, and suddenly we're way up there. So we went down, then we went up. So that up and down business makes me think of trig as well. Boy, that's a pretty high value there. Let's put in some approximations for trig values. So I'm going to put in 3.14. Wow, and that's a very large number. So my guess is that maybe at pi we're at infinity again. So we were at infinity at 0, and we're at infinity at pi, at least I think. Let's try pi over 2, or an approximation for that. I'm going to put in 1.6. And there we're pretty much at 1. So, and we're starting to see the shape here. It looks like we've got these sort of U-shaped curves. Well, we're only seeing one, but I think this is going to repeat itself because I think this is a trig function. So we've got a U-shaped curve here, and I'm guessing if we go out past pi, we're going to start to see another one. So let's put in 4 and 5, and 6. All right, so we've got, I think what we've got is a U shape here and a U shape here with these asymptotes where it shoots up to infinity and down to negative infinity on either side. And we've seen something like this before, and it was actually a combination of a rational function and a trig function. So we saw 1 over the cosine before, which is called the secant. I think this one is related. So let's think about the trig functions again. So at 0, if this points to 0, which is right here, pi is over here, and if it points to 0, the point that this line intersects on the unit circle is the point 1, 0. So 0 is the sign, the y coordinate is the sign. And since we're getting this infinity error at 0, I think we're dealing with the sign, but I think we're dealing with 1 over the sign. So at if we had 1 over the sign, 1 over the sign of 0 is 1 over 0, and it would be undefined. The same thing would happen if we go all the way around to pi. So here we're at the point negative 1, 0. So again, the sign, the y coordinate is 0. So at pi, we see that same thing. And I think just like we had for the secant, I think we're going to see these U shapes repeating, alternating on either side of the x-axis like this, with those points, the undefined points at 0, and then multiples of pi. So I think it's as simple as that. Just think about, we'll try one more point here just to get it straight. Think about pi over 2. So at pi over 2, we're at the point 0, 1. So 1 over the sine of pi over 2 is 1 over 1. So we should get 1 at pi over 2. And if we look at our approximation for pi over 2, we're basically at 1. So this is 1 over the sine of x. And there's another name for that. That is called the cosecant of x. So either one of those I think would be correct. Let's take a look and make sure we've got that right. Yeah, 1 over sine x or cosecant x, and we can graph that as well. If you remember the graph of the secant, this looks very similar. It's just shifted over in much the same way that the sine and the cosine are basically the same graph and just shifted over as well. Well, how did that go for you? Were you thinking trig? Let me know. Thanks, everybody.